KMAG, Delay Tolerant Network DTNPL, Permanent Shadow Region Camera from NASA ShadowCam. Danuri is launched toward the sun, not the moon. It will travel for about a month as the sun gravity pulls it. Finally, it will reach around the L1 Lagrange point, which is the point of equilibrium under the influence of the sun and the Earth's gravity. After that, when the TCM burn is started to make sure it can reach the moon on the desired date, it will be pulled by the gravitational force of the Earth, the moon, and the sun to travel several million kilometers. Then, it will naturally approach the moon that is revolving around the Earth. After entering the lunar orbit, Danuri will maneuver several times to reduce the orbit altitude. Finally, it will reach the mission altitude of 100 kilometers in polar near-circular orbit for 6 payload missions. LUTI is a high-resolution camera that has the mission to take images of the lunar surface. PolCam is composed of 2 cameras slanted by 45 degrees each to take polarimetric images of moon surface. The gamma-ray spectrometer is used to make a map of 5 major elements on the entire surface of the moon. Magnetometer is used to measure the strength of the magnetic field, which is invisible. ShadowCam will record images of the permanently shaded regions around the poles of moon where no sunlight can reach. DTNPL will conduct the world's first communication test on the moon.
From this time on, Korean space research and development will experience a very important turning point thanks to Danuri. It is a very significant milestone in the history of Korean space exploration. Danuri is just at the beginning. And if we are more determined and committed to technology development for space travel, we will be able to reach Mars, asteroids, and so on in the near future.
As we saw in the video, KPLO's final destination would be the moon, or a lunar orbit to be more precise. Traditionally, if we wanted to send something to the moon, we would launch the payload into a lunar transfer orbit, or a trans-lunar injection orbit. A lunar transfer orbit has an apogee altitude of approximately 385,000 kilometers, which is roughly the distance between the moon and the Earth. To support this type of launch, our teams would select a launch window that would allow the payload to meet the moon when it reaches apogee, and at that point, it would use its own propulsion to get into an orbit around the moon. Although this is the fastest approach, it also requires a significant amount of fuel for the payload to get into its final orbit around the moon. KPLO will instead be launched into a ballistic lunar transfer orbit, which will require KPLO to be launched into a much higher orbit of about 1.2 million kilometers, which is about 3 times higher than the lunar orbit we just saw. At this height, the gravitational pull from the sun starts becoming dominant compared to that of the Earth. The payload will then fire its thrusters to put itself on a return trajectory towards Earth, and this will bring it closer to the moon, where it will once again use its thrusters to maneuver into a lunar orbit. The ballistic lunar transfer approach takes much longer to get into the final lunar orbit, but it requires a lot less fuel from the satellite. So turning our attention back on screen, we see that the strong back, which is that gray structure next to the vehicle, it should begin to recline away from Falcon 9.
Strong back recheck in progress.
You can see on screen that it is indeed reclining to its pre-launch position. It is part of a larger structure called the Transporter Erector, also known as the TE. The TE's job is to roll the rocket out to the pad and raise it to the vertical launch position that you see on screen. It also routes the vehicle's fluids, powers, and telemetry umbilicals from the ground systems to the rocket and satellites until Falcon 9 goes on internal power and clears the pad. The strong back will continue to recline away from Falcon 9 as we get closer to T0 to provide clearance for Falcon 9 to lift off.
Stage 1 LOX load is complete.
Our team in Florida began loading propellant at the T-minus 35-minute mark, and we are nearly full on both stages. Falcon 9's first and second stages use the same two propellants. We use RP1 or rocket propellant 1 as our fuel, and super chilled liquid oxygen or LOX for oxidizing. In addition to these two propellants, we also use the chemical TTEB or triethyl aluminum and triethyl borane as an ignition source. The combination of RP1 and LOX is what makes the rocket go, but it's TTEB that sets the match to the propellant mix. So right now the weather looks like we're just a 10% chance of violating launch weather requirements. The launch vehicle, satellite, and range are all looking good for an on-time liftoff today at 7:08 p.m. Eastern Time.
Verificaciones finales antes del lanzamiento y se hará la presurización final de los tanques de combustible y de oxígeno líquido.
Stage 2 LOX load is complete.
That call out for stage 2 LOX load complete. That means that the vehicle is fully fueled on both stages and ready for liftoff just 90 seconds from now.
Muy bien, vamos. 1 minuto y 26 segundos. Todo listo para
we're starting to see some clouds form around Falcon 9 and hearing some hissing. That is normal and expected for us at this stage in the countdown. So things continuing to look good for an on-time liftoff.
1 minuto 10 y ya se acerca la cuenta. 1 minuto.
Falcon 9 is in
Todo va
startup.
por el momento según bien.
The vehicle is in startup, which means that both stages are beginning to pressurize for liftoff.
Vamos a 45 segundos, nos dirían que la verificación final de lanzamiento.
LD is go for 2 and 24.
The launch director has given the final go. All systems are go for launch of Falcon 9 with KPLO.
Estamos todos listos para el lanzamiento. El siguiente lanzamiento ya te
T-minus 30 seconds, stand by for terminal
será la
count.
misión Artemis 1. Mientras tanto, durante este tiempo voy a buscar formas de conseguir dinero para que podamos hacer la transmisión muy esperada para la misión
15,
Artemis 1.
14, 13, 12, 11, 10,
Muy bien, vamos.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Cero.
Ignition
Encendido y
and
lanzamiento.
liftoff. Countdown.
Tenemos lanzamiento, gente.
Vehicles PG downrange. Stage 1 propulsion is nominal.
Tenemos lanzamiento. Y abandonado la torre.
Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station, carrying the KPLO payload to a ballistic lunar transfer orbit. So we are beginning to throttle down the engines on the first stage to prepare for a period known as max Q. During this period, the vehicle is going to experience the highest amount of aerodynamic stresses
Vehicle
on the
supersonic.
vehicle.
Va a pasar por la parte de máxima presión aerodinámica, la presión provocada por el estrés estructural.
Max Q.
And there was max Q. So the engines are coming back up to full power. We have 3 events coming up in quick succession in about a minute. First up is MECO, that stands for main engine cutoff, followed by stage separation, and then SES1, which stands for second engine start 1. Main engine cutoff is where the first and second stages, main engine cutoff is where the 9 engines on the first stage will shut off in preparation for stage separation. That is where the first and second stages will separate from one another. The first stage will make its way back to our drone ship to attempt its 6th landing. And the second stage will continue with SES-1, which is where the Merlin vacuum engine on the second stage will start up and continue to propel our KPLO satellite to its desired orbit. Those events are coming up in about 10 seconds. For now, we are enjoying some excellent views of Falcon 9 during its ascent phase.
Ahí vamos. Una segunda para el main engine cutoff, o el apagado del motor principal. Muy bien, se hizo el apagado del motor principal y se hará la separación de la primera etapa. Hubo separación.
MVAC ignition.
Se enciende el
we saw the confirmation of stage separation and the ignition of the Merlin vacuum engine on the second stage. Coming up in a few seconds, we're going to be looking for fairing deploy. Those fairing halves will separate from the top of the second stage and make their way back to Earth.
Fairing separation confirmed.
And off they come. So those two fairing halves are now falling back to Earth. Those are the fourth flights for both of these fairing halves, and we are going to be attempting to retrieve them with the help of our recovery vessel, Bob. So we're coming up on T plus 4 minutes into the mission. We have a couple of views on screen. On the left-hand side is a view of that first stage, continuing to make its way back to Earth. And on the right-hand side is a view of the Merlin vacuum engine. On the opposite side of that engine is the second stage and the KPLO payload. So things continuing to go smoothly after liftoff. The next major milestone for the first stage occurs around the T plus 6 minute and 50 second mark. It's going to be the first of two burns. The first burn is going to be called the entry burn. This is where we will relight the center engine number 9, followed by engines number 1 and 5. That way we'll have 3 M1D engines helping to slow down the first stage as it passes back into the Earth's atmosphere.
Como diferencia, el aterrizaje de la primera etapa se hará 30 segundos después del corte del motor principal o el apagado del motor de la segunda etapa.
The engine that you see on the right-hand side of the screen is optimized to perform in the vacuum of space. It can produce over 220,000 pounds of thrust, as opposed to the engines on the first stage, which are optimized to perform at sea level. Those can produce 190,000 pounds of thrust apiece. This view that you see on the left-hand side of the screen, that's actually inside the inner stage looking up. We mentioned those pusher rods, and that we saw a glimpse of those with that video. You can also see some action on the left-hand side of the screen. We see some bursts of white gas. That is nitrogen from our attitude control system. That in conjunction with those hypersonic griffins that you see on screen. We see 2 of them. There's actually 4 at the top of the first stage. Those help to guide and steer and orient the first stage back to its targeted landing zone. Today it's going to be the drone ship Just Read the Instruction.
Así que todo bien.
We are about 40 seconds away, or 30 seconds away from that entry burn on the first stage. Second stage continues to perform nominally.
Muy bien, al parecer ya se orbitó la primera etapa para que pueda ser el encendido de entrada.
Stage 1 FTS has safed.
Muy bien, vamos.
Stage 1 1 entry burn startup.
Vamos a ver. Muy bien, se
And
hizo el
those
encendido
engines
de
have indeed
entrada
relit.
con 3 motores
The
del
first stage
1
is
de
currently slowing down before hitting the denser parts of the Earth's atmosphere. This burn is expected to last for about 30 seconds.
Stage 1 entry burn shut down.
Muy bien, se hizo el
Awesome.
apagado
So that
de
burn
la
is in the books.
primera
We have
etapa.
one more to go on the first stage. That's
Vamos
a
a ver
landing
si
burn
en
that's
esta
going to
transmisión
happen.
tenemos buenas imágenes desde la
In about a
barcaza o
minute.
desde la primera etapa durante la
We are going to be
durante el
listening here in
descenso.
about 20 seconds for
En
a
estos
call out
momentos parece que no
called
hemos
SECO,
tenido
that stands for
imágenes de
Second
de
Engine
la
Cutoff
primera
1.
etapa.
The engine that you see on screen will
Stage
shut
2
off its
FPS
engine,
has saved.
and then shortly after that, we'll listen for a call out for a nominal orbital insertion. That means that the second stage is entering its coast phase and is exactly where we want it to be
Pues parecer nos cambiaron
before
las
it relights
imágenes
its
con la
engine
segunda etapa.
a little bit later on in the mission.
Vamos, se hará el apagado de la segunda etapa. El C1 o el
MVAC shutdown.
corte de la del segundo.
So we did see that the
Muy
MVAC
bien, vamos.
Stage 1 transonic.
shut down.
Nominal orbit
Ya que
insertion.
nos cambie.
And there was the call out for nominal
que
orbital
esta es
insertion.
la fase de
The
aterrizaje.
second stage is coasting for a bit longer, and we got views back of our first stage as it attempts its sixth
Se hace el
landing on our
encendido de
drone ship.
aterrizaje. Tenemos imágenes de la primera etapa.
You can start to see the drone
Muy bien,
ship.
hay aterrizaje.
Stage 1 landing leg deploy.
Se acaban de desplegar el tren de aterrizaje. Veremos como al parecer se cortó
Sometimes the
durante
video
la fase
cuts
de
out.
aterrizaje.
We'll wait for confirmation of whether or not the first stage was able to land.
Necesitarán esperar unos
But
minutos
for now, we
para
know
que
that
nos
the
digan
second
si hubo
stage is
aterrizaje suave
in
o
its
perdieron el vehículo.
coasting orbit. And there is that second stage with the Merlin vacuum engine off.
Vamos
That's a view of the KPLO payload.
Expected loss of signal. Keep.
So we haven't heard confirmation of the first stage, whether it was able to land for the sixth time. But the second stage is now embarking on its coast phase between the first and second burns of the MVAC engine. After the coast phase, we'll light that MVAC engine for a second time, a bit after the T plus 34-minute mark.
Stage 1 landing confirmed.
And before we head off, we did get confirmation of the first stage landing. That is the 127th successful recovery of a Falcon 9 first stage and the 110th mission flying a rephone booster, which includes both Falcon Heavy and Falcon 9 missions. So we'll see you back here in about 20 minutes. In the meantime, enjoy the space tunes.
Dice que va a durar como mínimo un minuto del encendido. Y después, unos minutos después, se hará la separación de... No sé, yo lo llamaré sonda. Muy bien, tenemos imágenes del aterrizaje. Hubo un perfecto aterrizaje, pero no lo pudimos ver en tiempo real. Pues sí, eso tiene sentido, ya que el único que la barcaza que puede detectar estas señales provocadas por las vibraciones es la Shortfall of Gravity. Entonces de que podemos hablar en el cosmometro de que estamos con solo 20 minutos para el encendido de inyección translunar. Vamos a ver qué noticias tenemos hasta el momento.
Expected loss of signal, Bermuda.
Además de que dicen de que China al parecer lanzó hicieron un lanzamiento de prueba de una nave reutilizable secreta, pero no sabemos de esta estación espacial de que Roscosmos dejará la estación no antes de lo previsto de la desintegración que será que Roscosmos va a abandonar la ISS hasta el 2024. ¿Qué les parece si vemos el lanzamiento que no pudimos ver los dos lanzamientos? ¿Qué les parece? De los cohetes Electron y la cohete Atlántico. Vamos a ponerlo. Pues solo el lanzamiento, vamos a ver. Ya que
rooms and plenty of room in the integration hangar for multiple rockets. 2 launch pads equal double the opportunity when we don't have to wait for a single.
Okay.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And we have liftoff.
Stage 1 proportional is nominal.
Haciendo una, no sé cómo decirlo. También siento por parte de los de Australia, pues parece que ya no va a haber lanzamiento de la colaboración de la Oficina de Reconocimiento
HVB discharge looks
de
nominal.
Australia.
Entered burnout detect mode.
There we go, T plus 50 seconds into the NROL 199 mission on its Antipodean adventure. Electron's engines will soon power down slightly to prepare the rocket to pass through max Q, or the point of maximum aerodynamic pressure against Electron during launch.
Todo fue bien, pasando por el punto de máxima presión aerodinámica.
Cleared max Q.
Stage 1 propulsion is nominal.
And Electron has passed through Max Q, the rocket's first major test after leaving the pad at Launch Complex 1 on the coast. You see below there on your screen. Electron's 9 Rutherford engines are firing hot as they burn through the first stage's tanks of liquid oxygen and RP-1 propellant. T plus 1 minute and 42 seconds, and Electron's trajectory is also looking good. The rocket is at now over 30 kilometers above Earth and moving quickly at nearly 4,000 kilometers an hour.
Electron de otra persona, pero lo modifiqué de la misión porque solo había de dos, de la segunda y de la tercera vuelo del cohete Electron. Si alguien lo quiere, a ver si lo puedo, solo es una imagen.
10 seconds to Miko.
Misiones. Hasta tiene el logo tiene de la NASA. ¿Qué les parece? Muy bien, ya se saca la
Miko
aparato
confirmed.
del motor principal, que también cuenta con 9 motores eléctricos, y se hizo la separación de la segunda etapa.
There you heard it and saw it on your screen, all three events happening back to back through MECO, stage separation and second stage engine start. Currently on your screen is Electron's second stage, continuing nominally for the NROL 199 mission. Soon it will shed its payload protective fairing to lose the unnecessary weight now that the vehicle is in space. In fact, there it goes. We can see it falling away on our screen there. So the payload fairing has split in half and fallen away. The NROL 199 payload is now exposed to space in preparation for payload deployment, and Electron's second stage is continuing to orbit, carrying the kick stage and the payload. Everything continues to look nominal, with the Rutherford engine glowing bright as it powers the mission on. We have a second stage separation that enables our third stage, known as the kick stage, to carry on with the rest of the mission. Our kick stage is critical in delivering the NRO the exact orbital insertion they need for this national security payload. With its own reliable Curie engine, our kick stage can be
Stage 2 propulsion still nominal.
Look at that beautiful view from space. Everything is looking great so far on this Antipodean adventure. So they're discarded when we... We have had a clean run through mission milestones so far. It was only 7 or so minutes ago that Electron cleared the pad at LC1, having since completed successful passes through Max Q, main engine cutoff, and stage separation to reach this point now in the mission. Next up will be the second stage engine shutdown and the final stage separation that will follow the same process as the earlier MECO and separation of the stages, the first and second stages. So right now, though, with stage 2's engine still firing, the mission remains on its trajectory to orbit as expected, and all is going well for NRO.
Ay, perdón.
Acquisition of signal, Cabo. Bueno, ya sé. De la página oficial de SpaceX en el sentido de la inyección translunar se hará a las 34 con 15 segundos después del lanzamiento. Después te ayudo, le das esto. Bueno, ya. Algo que me interesa es que no solo los daban contando la cuenta atrás hasta tienen los 10 segundos, pero no nunca lo hicieron hasta
With KPLO.
De seguro ahí las personas lo pudieron notar.
14. Count. 15. 15. 14. 13. 12. 11.
Escuche,
15. 14. 13. 12. 11. 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. 0. Ignition. And Liftoff. Batteries, instantáneo. Vehicles reaching downrange. Stage 1 propulsion is nominal.
Pues así es como pasó. Iniciaron como que cambian algunas cosas. Llegamos a 2 minutos para el ejercicio de inyección tras inyección tras. Creo que nos dio la vez que venido aquí. Parece bien. ¿Cómo le quedan de nuevo? Bueno, eso que dice la misión Liu 2. Bueno, ya que solo ya llenos y no tiene sentido. No, es así que no. Mientras tanto le voy a decir de que, bueno, como les estoy contando de que voy a hacer una pausa hasta el lanzamiento de Artemis 1 para ver cuánto consigo de dinero para que mejore las transmisiones. Tengo dos posibles, es una que me compre una laptop con un procesador bueno, una unidad de estado sólido y una buena gráfica para las transmisiones, o dos de que ya conseguí dinero para una PC gamer con 3 monitores. Bueno, 3 monitores para una transmisión, otra la transmisión de SpaceX y otra
Expected loss of signal, Gabon.
Las noticias y otras cosas. Estamos acercando.
Welcome back to the webcast of the Falcon 9 mission carrying the KPLO payload designed and developed by KARI, or Korea Aerospace Research Institute. We're coming up on the second burn of the upper stage engine in about 30 seconds. And to recap what's happened so far in the mission, we had a smooth liftoff at 7:08 p.m. Eastern Time out of Launch Complex 40 in Cape Canaveral, Florida. The first stage, which made its 6th flight today, successfully landed on our drone ship Just Read the Instructions. So again, we are waiting for our second stage engine to reignite. And And then after that, we will shut it back down for another short coast phase before deploying our KPLO payload.
Muy bien. Iniciará el encendido en cualquier momento. Muy bien. Se hizo el encendido de inyección translunar.
It doesn't look like we are going to be getting video views of the second stage, so we'll be waiting for the call out of SES-2.
Muy bien, se hizo el encendido y se hizo el apagado del motor de la segunda etapa. Ya solo faltan 5 minutos para que se despliegue satélite órbita.
So we were waiting for SES-2 and SECO-2, but we got an even better call out, which is nominal orbital insertion. So the second stage engine started up, burned for about a minute, and then shut back down. Again, we are in another coast phase, and while we wait for the payload to get closer to its final destination, we're going to pause commentary during the second coast phase, but we will come back just before payload deploy, currently scheduled to occur around the T plus 40-minute mark. So until then, enjoy the space tunes once again, and we'll see you back here in about 4 minutes.
Bueno, hay que seguir esperando.
Acquisition of signal, Mauritius. Ponemos esto durante este tiempo. Por favor, les pido que no se vayan. Para la preparación del satélite orbitador.
welcome back to our launch coverage of the KPLO mission. If you are just joining us, we have just one more major milestone coming up to complete today's mission, which of course is the deployment of the KPLO payload from Falcon 9's second stage, which is scheduled to take place about 30 seconds from now. And there we can see the KPLO payload at the top of the second stage.
Dice que va a ser en unos segundos. En 16 segundos se hará la separación del orbitador, que ya dará 4 días en llegar hasta la Luna. Vamos.
KPLO deploy confirmed.
And there you have it. Confirmation of successful separation of KPLO from Falcon 9's second stage. KPLO still has a bit of work to do over the next 4.5 months before getting into a lunar orbit, but we do wish it safe travels. For us here at SpaceX, that is going to wrap up our webcast coverage. We want to thank the Korea Aerospace Research Institute for entrusting us with today's mission. And of course, all our viewers, thank you for joining us, and we will see you next time.
Mientras tanto hay que estar esperando para ver qué cosas puede. Bueno, pues esto sería todo para la transmisión de SpaceX. Pues voy a hacer todo lo posible para que podamos hacer la mejor transmisión de Artemis 1 que se pueda ver. Bueno, esto sería todo y nos vemos en un siguiente lanzamiento.
Booster ignition and liftoff of Discovery, celebrating its 25th birthday by racking up science and supplies to the space station.